Hello students, welcome to SOURAV sir's classes. Today I am going to solve the problem on the topic errors. Find the approximate value of to the power half 0.98 whole square plus 2.101 whole square plus 1.94 square to the power half. So you need to find the value of this. Okay, so how to solve it. The solution is, let f x y z is equal to x square to the power half, right? So taking x is equal to 1, okay, y is equal to 2 and z is equal to 2. See, y and z are very close to 2, so we can take them, and 0.9 is close to 1. Okay, so dx will be, just small part will be minus 0.02. If you subtract 0.98 from 1, you will get 0.1. Your dy will be 0.01 and your dz will be minus 0.06, right? Now from 1 df by dx is equal to the minus power minus half. Okay, so we have taken it. You see, here we have taken half, so to the power minus half, right? Then you have, and df by dy. What is df by dy? That is equal to y into x square plus y square plus z square to the power minus half, and then we have df by dz is equal to z into to the power minus half. So we have df is equal to df is equal to df by dx, okay, then df by dy, and plus df by dz by total differentiation, by total differentiation. Okay, now going ahead, we have df by dx of dx plus dy dz x square plus y square plus z square to the power minus half into so that becomes your 1 plus 4 plus 4 to the power minus half into 1 minus 0.02 right. So you have 1 by 3. See, 1 plus 4 plus 4, what is that? That's 9. 9 to the power minus half. That's 3 to the power minus half. So that becomes 3 to the power, sorry, 9 to, see, 3 square into minus 1 by half here. And this becomes your minus 0.02 plus 0.02 and then minus 0.12. So now that goes for you. You just cancel this. This becomes your 1 by 3 into, and then you have 0.12 with a minus sign over here. That becomes your minus 0.04. Okay. Now what you have is 0.98 whole square plus 2.01 whole square plus 1.94 and whole square, and then you have this half. Now you have f1 q is df. Okay. And that becomes your 2.96, and that's your answer. Okay. Now let's go ahead and solve another problem. This is from maxima and minima, and the problem is examine the function fxy is equal to y square plus 4xy plus 3x square plus x cube for extreme value. Solution: we have y square plus 4xy plus 3x square minus x cube, right? Now go ahead, and you will have, see this. See, p is equal to del f by del x. 4y del f by del x, so 4y, and if you differentiate y with respect to the rest becomes 0, so that's why 4y, and then plus 6x, that was 3x square plus 6x, and then you have plus 3x square, right? Now if you take r, that's delta 2 delta x square, then it becomes 6 plus 6x, okay? And then you have your t, will be your delta 2f by delta y square. If you find that, it will be 2, okay? Delta 2f by delta, and then your q is delta f by delta y, and that is 2y plus 4x, and s is your delta 2f delta x delta y, okay? For maxima and minima, del f by del x is equal to 0, and 4y is equal to 0, okay? Also that becomes your 1, and then your del f by del y is 0, and 2y plus 4x is equal to 0, so y is equal to minus 2x. Now that's the end of our problem. This is the second problem. So putting the value of y, putting the value of y from 2 in 1. Now which is 1 and which is 2? This is your 1 and this is your 2, okay? So that becomes your 4 into minus 2x plus 6x is equal to 0, and then three x square plus 6x minus 8x is equal to 0. 3x square minus 2x is equal to 0. X into 3x is equal to 0. So x is equal to 0 and two by 3. Now when x is equal to 0 and y is equal to when x is equal to 2 by 3 and y is equal to minus 2 by 2 by 3, is equal to minus 4 by 3. Thus, the stationary points are